Thank you everyone for attending today's webinar, Tips for 3D Printing Accuracy, brought to you by Design World Magazine. We would also like to thank our sponsors, 3D Systems and Object Geometries, as well as our presenters, Stacy Hockey of 3D Systems, Ben Klein from Object, and Bonnie Meyer from Stratasys for being here today. I'm Leslie Langnaw, Managing Editor at Design World, and I'll be your moderator today. Just a few housekeeping details before we get started. If you wish to tweet about this webinar, you can use the hashtag #DWWebinar, and we will also have a question and answer session right after everyone gives their presentation. But you can go ahead and submit your questions now, and we will ask them after the presenters have finished. You should be able to see a question box on the GoToWebinar section on your screen, and that's where you can enter them. Each of our presenters was allowed to address the subject of accuracy in general and in specific, so they will go into details about specific systems their companies offer. Our first presenter is going to be Stacy Hockey. She is an applications engineer providing support for the SLA, SLS, and ProJet product lines, resin material, and build style development. She serves as a technical liaison to integrate layer manufacturing into hearing aid and dental production, supports SLA product software management, and assists with a number of other special development projects. She is also the lead applications engineer on 3D Systems' next generation, the ProJet 6000, and which is a crossover system that delivers the power of SLA parts performance with the convenience of use of a 3D printer. Ben Klein is Applications Team Leader for Object Headquarters in Israel. He helps customers and partners discover new and innovative ways to use object printers. He also provides solutions in terms of post-processing, tooling, and molding. Prior to joining Object, Ben held a position for 3 years as a clinical engineer for VisionSense Limited, an Israeli-based medical device company. Ben holds a Bachelor of Science in Biomedical Engineering from Ben-Gurion University in Israel, specializing in medical image processing. And our third presenter, Bonnie Meyer, has a mechanical engineering degree from Michigan Tech with more than a decade of experience in applications engineering. During that time, she has worked with multiple additive manufacturing technologies, including both resin-based processes and fused deposition modeling. Bonnie has written technical papers applying additive manufacturing techniques to speed product development and improve manufacturing efficiency. As a senior applications engineer at Stratasys, she manages a team that works directly with users to help them maximize their productivity and profitability with additive manufacturing. So without further ado, I'm going to turn over the microphone to Stacy.
Hi everyone. Welcome. I am going to be doing a quick presentation on the ProJet 6000 accuracy. Leslie, it doesn't seem like I can change slides. Oh, there it goes. It's just slow. Sorry about that. All right, everyone. So I'm here to talk about the ProJet 6000 accuracy. Basically, our ProJet 6000 is our next generation crossover printer, and it is one of our most accurate printers available to date. This ProJet 6000 is part of our professional printer line, and we have accurate, precise, and high resolution on this system. When we say accurate, we have a digital self-calibrating print head that rivals CNC accuracy. We have digital motion controls with a closed-loop monitoring system and a less than 10 micron resolution, allowing us to get features as small as 0.3 millimeters. These are some studies that we have performed on our ProJet system. What this is it's an array of 9 parts built across the entire platform area. And then what we do is we measure different X, Y, and Z points on each of these parts. We have a total of 108 measurements that we take. And basically the results of our system is showing a standard deviation of less than 15 microns and an accuracy of plus or minus 45 microns across the entire build area. We also have done studies that not only define how accurate the mechanics of the machine are, but also what type of step increments can be measured on the machine. So what we have here is a test part where we increase the wall thicknesses by 10 microns. So each wall is 10 microns larger. And what this slide is showing us is that once we print this part, we can measure these walls and we show a 10 micron increment across each of the walls. So along with the hardware and the setup accuracy for the ProJet 6000, we have some configurable modes for the user. We have 3 different modes. There is an HD mode, which is your fastest mode, but it's also going to be your least accurate. We have a UHD mode, which is a general purpose build mode, what most customers use. Its XY accuracy and Z accuracy are slightly less accurate than in the XHD mode, but we find that it meets most people's accuracy requirements. And then, of course, we have a XHD build mode, which allows the user to get the finest feature in details on the system. So the whole reason of this presentation, I believe, is to train the end users on what they can do to make their machines more accurate. So with the ProJet 6000 system, we have 2 basic user configurable options that we encourage the user to change so that you can set up your machine to its highest accuracy level. Those 2 fine-tune accuracy components, one is called shrink compensation and one is line width compensation. The shrink compensation is going to adjust for material shrinkage due to the cure process, and because every single one of our print heads on these systems are slightly different, we see slight variations in the shrink for each machine. We recommend default shrink factors for all materials, and we encourage all users to start with those default values, but to fine-tune them so that you can get your machine-specific values to make your machine more accurate. So what you want to do is you want to build some parts and you want to take some measurements off your parts to fine-tune them. And what you see here is this is the user interface software on the ProJet 6000 system. Once you build your parts and you take your measurements, you will want to just adjust your scale factors. And as you can see here, we have independent X, Y, and Z scale factor values that the user can change. The other component that we encourage our end users to modify is something that we call a line width compensation value. This line width compensation value also adjusts for the material's cured line width. And of course, we have variation in these across the system due to individual machine head characteristics, the material that the user selects to use, and the build modes. Line width compensation, here is a screen kind of giving you an example of what line width compensation is. Basically, when you create a line in CAD, it has a start and end point, and it has no thickness associated with it. When we create a line with the ProJet 6000 system, that line actually has a thickness to it. So we have to adjust our outside borders of all of our geometries so that we offset that line in towards the mass of the part so that when we draw the line, the edge of the line defines the edge of the part geometry to make it accurate. What's interesting, if anybody has any CNC background out there, in CNC they have something that's called cutter compensation for the same reason that the files that they use to program the CNC machines with, the line defined there also assumes that the line has no thickness, but when you're actually cutting with a blade or a mill or a drill bit, that there is some width to that, and they just offset the opposite way. We're an additive process, so we need to offset in. CNC is a subtractive process. They need to compensate out. So for this project accuracy, we modify this in what we call our 3D managed software, which is the front-end interface, almost like the programming code for our Project 6000 system. And as you can see here, we have machine properties, and this small beam width compensation value is the value that we encourage each user to adjust for each machine material build mode combination for their system. So that is it for my slides.
Okay, thank you, Stacy. And now we are going to turn the presentation over to Ben.
Okay, hi everybody. Thanks to Design World for having us for this presentation. Just a short disclaimer maybe. This presentation is not going to talk about calibrating the machines, as the end user has no user configurable parameters. This is done by a customer support engineer. I'm going to talk about choosing the right print mode and material in order to get accuracy for your end part. So let's go ahead. So first thing that might sound very simple, but often we see files that do not have the proper resolution. When you are converting your files from CAD to STL, some people would just go ahead and choose the default parameters. Obviously, no rapid prototyping platform can build anything that is smoother than the STL. So if you're seeing coarse tolerance or smooth surfaces, that might be a reason. If we go ahead, so since our machines offer the connex ability, which means you can go with a multi-material part, if you go ahead and choose to build a distinct separation of bodies, you can save yourself a lot of work on an STL manipulation software. That way you can assign materials on the Object Studio software and choose the right material, let's say an elastomeric material, our Tango Black Plus for the tire and something else for the rim, which saves you a lot of work. So if you're sure to do that ahead, which typically is done on the export dialog, and note that that arrow does not go in the right place in that presentation. If you're going to go ahead and click to save, uncheck that save all components to a single file, then you get a few free separate STLs in the case of the tire you've seen on the previous slide, and you can go ahead and choose the correct tolerance and the correct deviation and get to connexify a part, as we call it. That is for the connex. Another way to achieve fine features is to support delicate part with the auxiliary structure. In that example you can see on the screen, it's a turbine blade for an automotive company, which was very delicate. The support removal process might damage those blades. So what we went ahead and did is create that calf over there, which, if you can see, has a small parting line inside, and that enables us to remove it once it's been printed and throw it away. This is not a part of the end of the final usable part. but still you can get your final part with delicate structure once you've printed something like that. Another way to get the final part appearance you are looking for is our difference between matte and glossy. So for us, matte, other than the typical appearance, would be everything that has interaction with support. Obviously, as you can see on the right picture, everything that interacts with support is going to be matte, and the glossy part is everything that is facing up. While the surfaces are more smooth and not and have a different appearance, some parts cannot be painted full glossy. So if you're aiming for that even look, you might want to go ahead with matte and post-process, polish lacquer with any off-the-shelf equipment, which would give you, as you can see, an even look on the left part, rather than the uneven look that cannot be obtained with those geometries. That obviously differs with the geometry, but that gives you the ability to get an even look. That left part is easier to post-process, obviously, since it is a one-time action and you do not have to consider different areas of the model. Another thing to appreciate is the difference between our materials. On the left side, you can see a very white part. On the right side, a very blue part. Those materials have the same properties, but obviously the right part shows the fine details a little bit more. So again, your choice of material would have a great effect on the way you can achieve the accuracy and the time you would need to spend after printing to post-process and get the appearance you want to appreciate. On to the next one. If you want, this is again coming back to the connex application, if you want to imitate the performance of something like a living hinge or a snap fit that you can see with the latches and the hooks, then you might want to use the connex. This is done by separating the shells. There was some cutting done along the line of the living hinge, the working part of the living hinge, to assign it to a different material. The material here is a combination, a digital material that is a combination of a Vero White and a Tango Black Plus. It gives it a show value which is typical for applications like a living hinge. Just note that the yellow material that you see is obviously not an object material, rather than a painted Vero White that the customer wished for his end product to look yellow. Another thing is for fitting surfaces. This is due to what we discussed with the support material. The upwards facing surfaces would obviously not need support. If you are trying to do a fit and assembly where the resolution and the properties of the bosses and pins are what you are looking for, that you might want to do the surfaces fitting upwards. That way you can fit them easier and you can appreciate better your CAD design in order to get those applications. Last one is, again, our connex ability to print several materials on a single piece. So this is a case of an American consumer goods company dealing with containers that wanted to test the show value that they're going to choose for the rubber gasket that they are using for their product. So the left image is the end product, and they wanted to evaluate the design. So again, just with a regular CAD work, nothing too complex, they divided into 4 pieces. On that right image over here, this is the original part, the left one. The right one has 4 different segments. And if we're looking at the end part, so the ability to get values, show values, all the way from 27, which is our unmixed or just base material Tango Black Plus, and if you mix it with Vero White, you can go all the way to show 90, give them the ability to print several materials and actually choose the final material before they went ahead and made the mass production of the same material. That is it from me. Thank you.
Okay, thank you very much, Ben. And now Bonnie from Stratasys is going to give her presentation.
Okay, thank you, Leslie. First of all, get to the next slide. Here we go. Just a quick overview of our systems. We have our Fortis lineup, which are meant for the shop or the factory floor, which have a variety of materials, larger build envelopes, and they use the Insight software. We have our Dimension printers, which are considered our work group printers, and then Uprint, which are personal printers. You could have this sitting on your desk or nearby your desk. And both Dimension and Uprint use our ABS Plus material and the Catalyst software. So first I'm going to go over a couple of tips and general info that cover all of these systems, and then a couple that are Fortis specific. Because when you have some higher performance requirements for functional prototypes or fixtures, finished goods, you need the capabilities of your system to increase as well, and the Fortis systems are engineered for these manufacturing applications. So all of our systems use thermoplastics, and thermoplastics are generally pretty stable over time. And when your parts have a service life of days, weeks, or even years, you want the accuracy of the part to not just be good out of the system, but you also want stability over time. So thermoplastics are generally much less susceptible to moisture, temperature, residual stress, and UV exposure, and so they can survive some of the more extreme conditions beyond like a climate-controlled office and get into more applications. So on our FDM parts, we've done a thorough analysis, and when you're producing more than one part for functional testing or a batch of finished goods, you also want to keep in mind stability and repeatability. So generally in additive manufacturing, there's variance between parts, between where they are on the machine, between machines, and we looked at, we did an extensive study to look at this capability and to see what our repeatability was. So, you know, similar to Stacy mentioned in her presentation, we did something similar. We had a test part that we built on, as you can see on the slide, several machines, several parts per build, and we took 27 measurements. So we had getting up close to 3,000 measurements that were taken. And the one thing that we did in our test were there were no adjustments machine to machine to dial in accuracy before we ran this study. And here's the results. You can see what the standard deviation and the mean are, and the text on the chart is kind of small, but what you see is that when you look at a curve like this, you want a curve that is high, tight, and centered on 0, and that's what we have here. And what it shows is that the majority of the dimensions fell within -0.02 of an inch to +0.03 of an inch. So over time, we had these parts. They were stored in a box in somebody's office, and after a couple of years, we took them out, took a few out of the box, and took a few measurements. And you can see here that there was very little change over time. So our machines are repeatable, and the materials are stable over time. But specifically, when you're at the machines, what are some things that can be done that would affect your part quality and your accuracy? First of all, it's just routine user maintenance. Just taking a few minutes to keep your system clean, vacuum out any material that is laying in the bottom, keeping an eye on any worn components. Our tips have an odometer to them, so they keep track of how much material has been run through, and will tell you when it is time to change the tips, as well as the tip brush and the flicker. Those tend to wear as well, and if you keep an eye on those and keep those clean, that will help your tip life and help the quality of your parts and the accuracy. We also recommend preventative maintenance, and this is done by our customer service team. and they go out and there's a whole list of things that they check and verify, and included in that are belt tensions, and they run calibration tests to verify that your X, Y, and Z motions are correct, and if any adjustments are needed, they would take care of that as well. Similar to what Ben had mentioned, we also suggest you keep your part orientation in mind. Critical features, anything that's important to your design, you need to be aware of where that's going to be oriented, especially any round features. They tend to build better upright or in the Z-axis, and small holes tend to be a little bit undersized, and also due to our process with the seam, or with the seam due to the start and end point of the bead of material, sometimes if you have a hole that is a very critical feature, you may want to drill that out or ream out that hole to get it to the dimension that you're specifying. Now getting into some of the Fortis system specifics. We have a calibration file that is run, and it's run when you change the tip, whether you're changing to a different size tip to change your slice in Z, or whether you're changing the tip to change to another material. Say you're changing from our ABS M30 to polycarb or to Ultim. We run a cal box, and that is to check and adjust the position of the support tip and the model tip relative to each other. So this should be done periodically. If you have a long build that's going to run for a day or two or more, if you have a critical build, you're on a tight deadline and you just want to take a few minutes to make sure that the machine is set up to the best it can be before you run your part. And these cal jobs take less than 10 minutes to build and check. Now, we talked about our machines are repeatable. And typically, the parts that we build are better than our stated tolerance of plus or minus 5 thousandths. But if you're building a quantity of parts and you need that accuracy to be dialed in even tighter, you can do custom scaling using the Insight software, and you can separate X, Y, and Z, and that can tune it in even tighter when necessary. And this is possible because our systems are repeatable, part to part, batch to batch, and machine to machine. So I went over a few things that are kind of general FDM system subjects, stability and repeatability of our machines and our materials, keeping your system clean and maintained the way it's recommended, and part orientation. You know, it's going to be geometry dependent, excuse me. But in general, you know, rounds and gradual slopes should be upright. And then specific for the Fortis systems, keeping your machine calibrated periodically, and then the ability to custom tune in that accuracy with the custom scaling. So for more information, you can go to our website. We have a white paper on accuracy, and also our application engineering group is always willing to answer questions and help out, and our resellers will be happy to work with you with any benchmark of your individual part or file. And that's all I have, so I will turn it back over to Leslie for any questions.
Thank you, Bonnie. I appreciate that, and thank you, everyone, for your presentations. We are now going to have the remaining time open for questions, and we do have some that are coming in. One of the ones that's come in is regarding, are there any special tips on maintenance for the object and the 3D systems? So Stacy and Ben, you guys can kind of trade off.
So let me answer. So as far as the maintenance goes, our wizards, our software on the embedded computer would go ahead and notify you if you have to do a cleaning of the heads, which is a simple solution that is covered in the basic training. It's done with a piece of fabric and some ethanol. Other than that, routine calibration has to be done by a customer support engineer. And as Stacy said, always make sure your machine is clean, that your build tray is clean, but nothing more than that. It has to do with calibration. There's no way use customizable things that has to be done over time.
Okay, Stacy? Okay, we'll move on to another question here. Regarding materials, do you have to, do they play a role as far as the kind of accuracy that you're going to be getting? And anybody can answer that one.
I'll start.
Will you repeat the question? Sorry.
I'm sorry. Regarding accuracy and your selection of materials, what role does that play as far as your accuracy? How does it affect your accuracy?
So for 3D systems, all of our materials are truly different materials. And so each of them have different default shrink parameters. So most of the time, you're going to want a material that has lower shrink. But we have parameters included into our build process that compensate for the variations in shrink. So most of the time, the end result is all of our materials are very similar in the repeatability and accuracy of the part.
Okay. Bonnie, we're going to answer that too.
Yeah, it's very similar for us. There are different shrink factors for different materials because our materials run at different temperatures. But that is all factored in behind the scenes, and that's not something that a user needs to adjust. It's all figured out ahead of time in the back-end software.
Okay. Is there a way to design parts on the Object 30 so that there is no burr between, and I didn't get the rest of that question.
So let me answer generally about the way that the Object 30 is working. Is the same approach that you would take with the professional gate system or the conic systems. So the support mechanism, if I get the question right, is going to work the same. Everything that is overhanging is going to get the support structure built into it. One thing that is customizable is the support grid, which may be heavy or light, meaning that the density of the support is going to be slightly different, which contributes to easier removal of support. If you have a large container, for example, you would like to remove the support more easily. Other than that, there's no difference between the system. So this is the way to. So if you're migrating from a smaller system to a larger one, you can still keep your tray files or your designs, and there are no special considerations.
And I believe this is a follow-up question, Ben. Can your materials stand up to steam autoclave? And it says, if so, have you studied? But I didn't get the rest of that question either.
So our materials for the Object 30 currently there's no offering that would go up to the temperature that's needed for an autoclave. Our highest HDT, heat deflection temperature material, is the ABS-like, which is a digital material which is offered on the conic systems. With the proper post-processing, you can get up to 95 degrees Celsius. I don't know what it is in Fahrenheit, which should be enough for autoclave to autoclave. Other than that, for the Object 30, there is no such material.
Okay. And what is the tip life? And I'm thinking that's going to be for everybody. On average, what can a user expect as far as their the printer head tip life?
Well, for us, we have the tip odometer, and that varies by material. So I don't have the exact numbers. I guess if you were looking general, it depends on how much material you run through it. So it's a little difficult to give a time. We're not talking days, though. It could be weeks of building or more, depending on the type of parts you build and how much you use the system.
Okay. Stacy or Ben, is that something that affects your systems as well?
So this is Stacy from 3D. The Project 6000 doesn't have a tip life, but it has a printhead life. And all new systems come with a 2-year printhead guarantee. So basically no cost to the user for any printhead issues for the first 2 years, and we expect it to last longer than that.
Okay. Ben, do you want to chime in?
So for us, it's a matter of printing hours. So this is a question of your throughput, but we're talking anywhere between 3,000 to 5,000 printing hours. And for the professional grade system, the first head is included with the system, so we can expect as much more with the price included. That typically amounts to more than a year of high volume work. But again, it depends on your workload. If you're printing 24/7, it's going to take less, obviously. And this is something, again, a customer support engineer would need to replace.
Okay. This wasn't addressed to anyone in specific, but it might be applicable to all of you. Do you have software that assists a designer in overcoming stair-stepping?
So this is Stacy from 3D. Stair steps are very much a build mode dependent for us. So depending on which build mode depends on the step size that you get. We've also improved our pointing accuracy on the machine, and we've found that even though our stair steps are generally larger than the other systems, our stair steps are around 0.05 to 0.1 millimeters, that if we angle the parts, as long as there's not shallow stair stepping, that it almost eliminates the effect of the stair stepping from the pointing. But as far as the software goes, the only options in the software are the selections of modes which dictates the stair stepping size.
Okay, anybody else want to address that, or we can move on to the next couple of questions?
We're similar. You can, with FDM systems, you can, in the software, you can choose the slice height, so that will affect your stair stepping, how much it's visible. And also in the software, it's not so much overcoming it, but you can also you can visualize each layer and visualize the part and see how the layers. So if you wanted to try a different orientation and see how the stair stepping or how the layers would affect a certain area, you can visualize that in the software as well. But it's not an automatic. It's not an automatic way of overcoming the stair stepping.
And somebody responded to you, Bonnie, about the tip life. They have replaced an ABS support tip that had close to 700 cubic inches.
Okay.
On it. They just
so that'll be, yeah, they'll be running quite a long time with that amount of material.
Here's a question for, I believe, 3D Systems, or no, this is for you, Bonnie. Are there any future plans to increase the Z resolution for FDM?
Since I work with the sales department, they don't really tell me things like that. I'm not part of the R&D, and I'm sure they're looking at all kinds of improvements on FDM systems, whether it's slice or materials or speed, any of those things. We look at a lot of them, but I can't speak to anything specific.
Okay. Another question that came in, what file extensions are best to use? And I think that applies to all of you.
As far as, I think everybody takes an STL file.
Mm-hmm.
I know that's what we take, and that can be exported from any CAD program.
I'm going to throw a ringer question in here. Well, not really a ringer question, but I'm going to throw an offside question. Are any of you working on being compatible with the new AMF file?
So
that I don't know.
Yeah, I was going to say, my answer would be the same as Bonnie's. You know, I only know about what they've got once they have it ready for release.
Okay.
So let me try and answer that one. So we have viewed the new AMF file. This is typically what's nice about that format, that it's backward compatible, and we can so your designs with STL are going to be the same, and it does have a nice solution for some of the challenges that involve multi-material capabilities. Having said that, we still do not have any clear roadmap for whether we're going to go ahead and support it in the foreseeable future.
Okay, and Ben, this is a question for you. Can you sputter coat an object part?
I'm not sure I know what sputter coating is.
Okay. Don't think I know either.
I can go ahead and say that because our parts are acrylic based, and any post-processing method that would work with acrylic plastic parts would work. That implies to glues, lacquers, and paints. What we typically advise our users is to just get anything off the shelf or use the in-house knowledge to paint it lacquer. We have yet to find a post-processing method that did not work from the regular ones. That, of course, if the process does not run very hot or over our specified heat deflection temperature, then you can use those processes.
Okay, and let's see. This is for all of you. Do your support structures for holes require significant post-processing?
So, yeah, go ahead.
So
you go
this
first.
is Stacy. This is Stacy from 3D. Most of our holes, it all depends on the holes, but most of our holes don't require supports. So one, it would not add any additional time. And then two, all of our supports remove the same depending on if they're on a down-facing surface or a hole or whatever. They're a very simple, just pull-apart removal. So my answer would have to be no.
Okay, so for an object, it's pretty much the same way you remove support from the structure. The support material is a gel-like material that is easy to mechanically remove. If those are hard to reach areas, you want to soak your parts for about 20 minutes in caustic soda mixed with water on a low concentration. That would release the support, and then you can just wash it away with water or air, which is easy to achieve. There is no post-processing that is involved other than just removing it. I just use a scraper to do it. It's typically very easy. If you want to refrain that, you can print an insert which goes inside, and then you remove it the same as I've shown on the example with the turbine blades. So you can have something to occupy that space and just throw it away. If you would like not to clean the support or not to go very deep inside the cavity if you have something like that on your design.
Well, we have two types of support material. We have our breakaway support material and we have our soluble support material. So first of all, it would depend on how the hole is oriented if there's support in it. If it's upright, there's likely not even to be support in it, so it wouldn't require anything special or extra. And two, if there is support in it, and it's the soluble, you're using the material that has a soluble support, that part would just go into one of our water tanks, which has, our water tanks are heated, and then there's agitation, and then there's basically like a detergent in there to dissolve away that support material. So it would depend on, the only thing that would be variable is the size of the hole would affect how long it would be soaking in that tank. But there's really no special post-finishing that needs to be done to remove the support different than the rest of the part.
Okay, there's another question here about, do any of you have plans to have software, or does your software fix bad STL files? Our Insight software and the Catalyst software, for that matter, it can do some, it will overlook some issues, some minor issues, and you do have the ability in the software to edit things, whether, say it's an assembly that they didn't quite get everything close together so it intersects, so there's maybe just a line. You can go in there and do some editing to that. And on the other side of that too, not just fixing files, but you can optimize your files a little bit. Say they didn't leave a big enough clearance between two parts. You can offset lines. You can draw some basic geometries and do some other editing in Insight software as well. Anybody else want to touch base with that question?
So this is Stacy. We have a 3D Verify program that's an automated auto fix program that works on a lot of geometries. If the STL has massive issues, this is not an user interaction software, it's an automated software. So it does not fix massive issue problems, but it does fix a lot of the standard STL file issues, and we encourage people to run that prior to going through our prepare process.
Okay, there's kind of a follow-on question, and this one's for Ben. Regarding setting the parameters for an STL file, what are the proper values for chord height and angle control for the best results in an object printer?
So, there's two sides to the questions. Since our printer has a resolution, the smallest feature is the 0.1 millimeter, so we want to go with half that parameter, so 0.005 millimeter for the chord height, and the angle should be 5 degrees. That is the typical size of the typical parameter. Obviously, if you have very big slopes, very big soft gradiating slopes, you might want to make the angle a bit lower, but there's no reason to have higher resolution than that for the smallest features, since the printer would not express them in the real model. So to sum up, 0.005 millimeters for the parameter and 5 degrees for the deviation angle.
Okay, and there's a kind of an additional question about the holes. Does the post-processing of holes change the accuracy of hole sizes or hole-to-hole tolerances?
This is Stacy. For the Project 6000, the answer would be no.
Again, this is Ben, for object printers. Since this is a different material, there's no dimensional inaccuracy that has to do with removing the support from the holes. So this would not change the accuracy of the holes.
Yeah, the same for us. Support removal isn't going to change any dimensions.
Okay. And this is a question for Objet. Different software interprets STL files in different ways. For example, often when I have files prepared in Rhino and Rhino does not show any errors, Magix finds the errors in the same files, like overlapping triangles. I understand that it is not a problem of the Connex, but rather the problem of Rhino. However, how critical are these errors for accuracy in Connex 500? Have you ever considered this situation?
When we know with some free-form software, typically Rhino and Google SketchUp are the most common ones, you would see zero thickness models and overlapping triangles. The Object Studio software, as long as there's a confined volume for each assembly, it's not going to be an issue. For example, if you have a closed sphere and some loose triangles in the middle, that's not going to be a problem because the software would look from outside in. The problem starts when there's an unclosed contour or missing triangles. So keep in mind that Magix is a general purpose software for rapid prototyping, and it does look on other technologies which interprets the STL files differently. So we do have some experience with printing those models which show overlapping triangles, typically on the inside internal surface of the model, which are not an issue. A rule of thumb is that the Connex or Connex Eden or desktop printers would not start a build if this is not a closed contour. Sometimes you would see the models alert you for an issue, but you can still go ahead and print that. From my experience with printing, those internal structures should not be a problem.
Okay. Are there any plans to have for any of you to have your software check for minimum wall thicknesses and either tell the users or possibly to alter the STL program and thicken the walls?
We do have a filter minimum wall thickness in Insight. Actually, it's in it goes by default in Catalyst, I believe, and then it is available as an option in Insight. And it won't change your STL file, but it will modify when it slices the parts, and you can set what your tool paths will be in that area, and then it will adjust to that, and it will highlight those areas in a different color so you can see what was changed as well. So it is in Insight.
Anybody else?
So this is Stacy from 3D. We have an option that's configurable in what we call our 3D Managed Setup software, where you can select an option called Small Feature Preservation. So that means when your wall thickness blends down to 0, if you want it to build, even though inaccurately, out to where that feature is, you have the option of selecting that.
Okay. There are several questions that are inquiring about prices, both of systems and materials, and I'm going to suggest to all of the attendees that if you have those questions, you see the slide on the screen right now that has everybody's email address, that you email specifically those people that you're interested in finding that information about. Everyone's system is priced differently, and every material is priced a little bit differently. So I suggest you contact them directly for that kind of information. But are there any other questions that anybody has in the last few minutes that we have for this webinar? Okay, one from this other person is, what is the softest material for the HD 3000?
So that's a question for me, Stacy, because an HD 3000 is a ProJet HD 3000, and I don't know off the top of my head. I'll have to get back to him. So please email me, and I'll make sure I get you that information.
And this is one for Bonnie. When you remove soluble support material, how much does it affect the accuracy?
Support removal doesn't affect your accuracy. the accuracy comes into play when your part is built, and removing supports, whether it's soluble supports or breakaway supports. The only way that would affect the accuracy is if you physically did something to your part afterwards, but the support removal isn't going to affect the accuracy.
Okay.
Real quick, Leslie.
Yeah.
There's been a lot of questions about that. It talks about supports and holes. Mm-hmm. And just a general comment to all the users out there, all the geometries or all the technologies are basically the same. The parts are very accurate. The inaccuracies come if you can't get the material out of that area. If you're having a hard time removing the support, you know, in my case it would be a liquid that's in the area. Basically, the accuracy of the part is still going to be there. You just need to make sure that you remove all the excess material so that you don't see the effect of that excess material affecting the accuracy of the part.
Okay. Any more questions? There have been a few that came in, like one was asking if you all offer a desktop Swiss system, and I put down yes, because you all do. Mm-hmm. Okay, if there are no more questions, just a reminder, everyone's email address is listed on the slide in front of you. There's also their phone number if you want to speak with them directly, and they would be able to help you with more specific questions. So thank you all again for attending this webinar. It's going to be emailed to you, at least the URL will be emailed to you in a couple of days. It will also be available online at our website, www.designworldonline.com. So thank you all again for attending, and have a great afternoon.